Nobody planned what happened over Scandinavia that autumn night in 1940. A violent storm had torn across the English coastline, ripping dozens of barrage balloons from their moorings and sending them tumbling across the dark waters toward continental Europe. These enormous hydrogen bags, designed to protect British cities from low-flying German aircraft, were now just expensive debris, scattered by nature's fury. Then the reports started trickling in. The Swedish power grid had gone dark. Danish radio equipment lay in ruins. Somewhere in Finland, electrical fires had erupted without explanation, all attributed to wayward British balloons that had drifted hundreds of miles before tangling with infrastructure nobody expected them to reach. Most military officials shrugged it off. An embarrassing accident, a waste of equipment, something to clean up and forget. But deep inside the corridors of Whitehall, somebody was thinking differently. Somebody looked at those damage reports and saw not an accident, but an opportunity. What if Britain could weaponize the wind itself? The answer would become one of the most bizarre, economical, and devastatingly effective military programs of the entire Second World War. The impossible math of strategic bombing. To understand why the British would eventually turn to weather balloons as weapons, you have to understand just how badly conventional bombing was failing them by now. Here's the brutal reality that RAF Bomber Command faced every single night. Sending heavy bombers over German territory meant gambling with resources Britain could barely afford to lose. A single Lancaster bomber required 7 highly trained crew members, pilots, navigators, bombardiers, gunners, each representing years of specialized instruction that couldn't be rushed or replaced. Lose one aircraft over enemy territory, and you didn't just lose metal and engines, you lost irreplaceable human expertise that money alone couldn't rebuild, and the losses were staggering. German anti-aircraft defences and night fighters were tearing through British bomber formations at rates that threatened to bleed the RAF dry. The mathematics were merciless. Each successful raid cost the equivalent of several £1,000s when accounting for aircraft fuel, ordnance, training, and the incalculable value of veteran crews who understood how to survive over hostile skies. Yet for all this sacrifice, the results were disappointing. Reconnaissance photographs taken after raids that had cost dozens of aircraft revealed an uncomfortable truth. German factories were back in production within days, sometimes within hours. The Reich's industrial machine absorbed punishment and kept churning out tanks, planes, and ammunition, as if the bombs had been minor inconveniences rather than strategic attacks. The problem was accuracy, or rather the complete absence of it. Navigation technology in 1941 couldn't reliably place a bomber within several miles of its intended target. When flying through darkness and cloud cover, bomb sites scattered ordnance across wide areas rather than concentrating explosives on specific buildings. Area bombing terrorized civilian populations, but rarely achieved the strategic paralysis that military planners desperately needed. Britain was spending fortunes and losing irreplaceable men, while Germany's war production barely noticed. The target that couldn't be hidden. There was, however, one German vulnerability that haunted military strategists. The Reich's electrical grid represented an enormous interconnected system, hundreds of power stations feeding thousands of miles of high-voltage transmission lines that stretched across the countryside like exposed arteries. Knock out enough of those arteries simultaneously, and even functioning power stations became useless. Electricity couldn't reach the factories that needed it. Production would grind to a halt, not because plants were destroyed, but because they had no power to operate. It was an elegant concept with one fatal flaw. Power stations were tiny targets compared to cities. Hitting them accurately at night with 1941 bombing technology was essentially impossible. And the transmission lines themselves? Miles upon miles of cables strung between towers across vast rural landscapes? No conventional bombing raid could hope to sever enough of them to matter. The grid seemed invulnerable, too dispersed to bomb effectively, too extensive to target piece by piece, too resilient to collapse from random strikes. Unless you could attack every rear at once, unless you could strike unpredictably, cheaply and endlessly, unless you could make the wind do your fighting for you. Churchill's memo and the birth of outrage. When reports of the accidental Scandinavian damage reached Winston Churchill's desk, the Prime Minister responded with characteristic imagination. His memo to the War Cabinet suggested Britain might make a virtue of our misfortune, transforming an embarrassing accident into deliberate strategy. The Admiralty began serious investigation. Captain Gerald Bannister, working in the Boom Defense Division, became the program's most passionate advocate. He faced skepticism from nearly every direction. The Air Ministry worried about endangering RAF aircraft. One memorandum, preserved in naval archives, objected that attacks of this nature should not be originated from a cricketing country, as if unsporting warfare concerned bureaucrats more than winning the actual war. The Chiefs of Staff finally approved the operation in autumn 1941. What emerged from the planning process was elegant in its simplicity. Britain possessed enormous stockpiles of standard meteorological balloons, 8 feet in diameter, constructed from latex rubber, completely useless for their original purpose, but sitting in warehouses across the country. Nearly 100,000 of them, surplus inventory that cost nothing to repurpose, filled with approximately 268 cubic feet of hydrogen. Each balloon could lift roughly 18 pounds, enough to carry a weapon payload across the North Sea, enough to become instruments of strategic sabotage. Wire and fire, the payload systems. 2 distinct weapon types were developed for Operation Outward, each targeting different aspects of German infrastructure. The first design focused on the electrical grid itself. Imagine a balloon drifting at altitude, trailing behind it 1,000 feet of combined hemp cord and steel wire, specially straightened piano wire, 15 gauge, capable of withstanding 1,000 pounds of tension before snapping. As the balloon descended over German territory, this trailing line would drag across the landscape. The physics were devastating. When that wire contacted high-voltage transmission lines, it created phase-to-phase electrical shorts that German protective systems weren't designed to handle. Testing at British research facilities demonstrated arcs capable of spanning 15 feet, enough to melt molybdenum conductors and destroy transformers on contact. And unlike bombs that exploded once and disappeared, these shorts could cascade through connected systems, triggering failures miles from the initial contact point. The second payload type targeted Germany's forests and agricultural lands. Canvas bags stuffed with wood shavings soaked in paraffin wax could burn white hot for 15 minutes after snagging in tree branches. Glass bottles filled with phosphorus compounds would shatter on impact and spontaneously ignite. Metal canisters of incendiary gel created fireballs 20 feet wide upon detonation. Each balloon carried an ingenious altitude control mechanism. Internal cords attached to spring-loaded valves would tighten as the balloon expanded at higher altitudes, automatically releasing hydrogen around 25,000 feet and triggering gradual descent. Slow-burning fuses calibrated to estimated flight times controlled exactly when payloads released over enemy territory. 8 hours after leaving British soil, these weapons would begin their silent work. Golf courses, women warriors, and hydrogen fires. 3 launch facilities operated along England's eastern coastline, positioned roughly 50 miles apart to maximize coverage of different wind patterns. The primary site occupied the fairways of a Suffolk golf club. HMS Beehive became the naval designation, though the establishment was hidden in plain sight at Felixstowe Ferry. A golf course provided ideal open ground for balloon inflation, while the military cover story explained the strange activity to curious locals. The workforce tells its own remarkable story of roughly 233 personnel at each facility. 140 were women serving in the Women's Royal Naval Service. These Wrens, as they were universally known, handled the dangerous work of inflating hydrogen-filled balloons while wearing flesh jackets, protective hoods with copper gauze faceplates, fireproof gloves, and specialized hand cream designed to prevent static discharge. Despite meticulous safety protocols, burns were common. Miraculously, no fatalities occurred throughout the program's operation. Working with hydrogen required treating every spark as potentially lethal. Balloons were inflated inside 3-sided canvas shelters, while water sprayed continuously over the latex to prevent the static buildup that could transform a weather balloon into a fireball. At peak efficiency, crews could launch 10 balloons per hour. By August 1942, operations were releasing 1,800 balloons in 3 to 4 hour bursts. Weather determined everything. Westerly winds at operational altitudes necessary to carry balloons toward German territory occurred roughly 55% of the time. The easterly winds that might have enabled German retaliation, only 38% occurrence. Nature itself favored the British offensive. When piano wire met power stations, the first operational balloons launched in March 1942. Intelligence reports of forest fires near Berlin and in East Prussia confirmed the incendiary payloads were reaching their targets, but the wire-carrying balloons would prove far more destructive than anyone anticipated. On a July day in 1942, a single balloon released the previous afternoon drifted over the German countryside near Leipzig. Its trailing wire made contact with a 1110 kilovolt transmission line, creating exactly the kind of phase-to-phase short circuit that British engineers had designed it to produce. At a nearby power station called Boulogne, protective circuit breakers failed to trip quickly enough. The resulting electrical surge threw one of the station's massive generators, 16.5 megawatts of capacity, out of synchronization with the grid. The rotor shaft bent under forces it was never designed to withstand, creating mechanical interference with the stationary components around it. The explosion and subsequent fire destroyed the entire facility. 250 megawatts of generating capacity eliminated. Material losses estimated at £1 million, roughly 5 times what the entire balloon program had cost to that point. A 35-shilling weather balloon, roughly £2 counting operational expenses, had accomplished what a squadron of heavy bombers might have failed to achieve: chaos across the Reich. German records captured the escalating disaster. Between March 1942 and January 1943, a period during which approximately 25,000 balloons had been launched, the Reich documented 520 major disturbances on high-voltage lines rated 110 kilovolts and above. Tracking incidents on lower voltage systems was eventually abandoned because they occurred too frequently to record. In occupied France alone, 9,046 power interruptions were attributed to balloon attacks. When wires severed conductors on one side of transmission towers, the unbalanced mechanical forces sometimes collapsed entire structures, multiplying damage far beyond the initial electrical failure. The economics was staggering. Every balloon cost Britain roughly £2 total. Every bomber sortie cost thousands. Analysis published in engineering journals decades later concluded that in certain months, balloon attacks inflicted more electrical damage than conventional bombing at a fraction of the expense, and with zero risk to British personnel. Germany's counterproductive responses. The Luftwaffe attempted interception, dispatching fighter aircraft to hunt balloons drifting silently at altitude. One documented effort assigned 250 fighters to a single balloon wave, burning fuel and ammunition worth vastly more than the latex targets they were chasing. Pilots found the work frustrating and often futile. Each hour spent pursuing balloons was time not spent defending against actual bomber raids. Anti-aircraft batteries engaged balloons whenever they could, again expending resources that far exceeded anything Britain had invested in the targets. Early warning systems, searchlight networks, observation posts. None could reliably predict where wind-carried weapons would descend or which transmission lines might be struck. German electrical engineers tried systematic solutions that backfired spectacularly. Increasing circuit breaker sensitivity caused protective systems to trip from bird strikes in normal weather conditions, creating outages where no balloons had even reached. The cure produced more disruption than the disease. Most disastrously, a politically connected Nazi engineer designed new transmission line clamps intended to safely release conductors if balloon-induced forces created dangerous imbalances. Over 1 million clamps were manufactured and installed across the Reich's power network. The design was fundamentally flawed. Normal wind and ice loading triggered the release mechanisms, dropping conductors and creating additional outages that had nothing to do with British attack. Because of the engineer's political position, it took considerable time before transmission specialists could prove the clamps themselves were causing damage. Eventually all had to be removed and replaced, an enormous expenditure of labor and materials during a war that demanded both. A 1943 military order captured German frustration perfectly. Units were warned about enemy balloons carrying spiral wire coils with hooks, capable of creating shorts that lasted for days and disrupted military readiness indefinitely. Assessment and legacy. The operation continued for 89 days before hydrogen supplies were diverted to support the Normandy invasion in September 9. By final count, 99 42 balloons had been launched from British soil. Post-war investigators from Britain's Central Electricity Board travelled through occupied Germany to examine captured records. They documented minimum damage exceeding £1.5 million. emphasizing that this represented only what could be verified. Records from Soviet-controlled zones were unavailable. German documentation had become increasingly unreliable after 1943. Lower voltage incident tracking had been abandoned entirely years earlier. Their conclusion: the results of Operation Outward were out of all proportion to the manpower and material employed. British officials described the impact as equivalent in naval terms to losing a capital warship, achieved not through naval combat but through weather balloons and piano wire. Why Japan's balloons failed where Britain's succeeded. The comparison with Japan's Fugo campaign proves instructive. Beginning in late 1944, Japan launched over 9,000 sophisticated balloon bombs designed to cross 5,000 miles of Pacific Ocean, riding the jet stream. These were engineering marvels, paper and rubberized silk constructions, with barometric altitude controls, multiple sandbag ballast systems, calculated to maintain proper height across a 3-day transoceanic journey. The results? 6 American civilians killed when they discovered a downed balloon in Oregon. Tragic, but strategically meaningless. American authorities suppressed all news coverage, denying Japan any feedback about where balloons landed or what they achieved. Operation Outward caused massive documented infrastructure damage with no confirmed casualties. Britain accomplished far more with simpler technology, shorter distances, and vastly lower costs. The weapon matched the target. Electrical systems couldn't shoot back, couldn't dodge, couldn't adapt quickly enough to nullify attacks that came from everywhere and nowhere simultaneously. Rude messages and ironic theme songs. The women who operated these launch facilities developed their own traditions. Veterans interviewed decades later for oral history collections recalled writing crude messages on uninflated balloons, insults directed at Hitler and his inner circle that became prominently visible as the latex expanded toward its full 8-foot diameter. Their unofficial theme song, "I Don't Want to Set the World on Fire," especially appropriate given that half their balloons carried incendiary devices designed to do exactly that. When winds shifted unexpectedly during one operation, a balloon blew back over English territory and knocked out power to the entire town of Ipswich. Local newspapers, completely unaware of the secret program, attributed the outage to some terrifying new German weapon. The Wrens presumably found this hilarious. The virtue of simplicity. Military procurement typically rewards complexity. Bigger weapons, more sophisticated systems, higher budgets. The Pentagon didn't invent cost overruns. Human nature pushes toward building impressive things rather than effective ones. Operation Outward embodied the opposite philosophy. Surplus balloons nobody wanted, piano wire from instrument makers, canvas bags, and paraffin wax. Technology available to any moderately industrialized nation. What made it devastating wasn't engineering sophistication, but rather strategic clarity. British planners identified a vulnerability, electrical infrastructure that couldn't be hidden or hardened, and found the cheapest possible method of exploiting it continuously over years. No pilot training required. No replacement crews needed when aircraft were lost. No enemy fighters capable of mounting effective defense. £220,000 total expenditure. Damage exceeding £1.5 million documented. Like them, far more undocumented. 0 British casualties. German responses consistently costing more than the attacks they tried to prevent. The wind as weapon. Those accidental balloon escapes in September 1940 could have been forgotten entirely. Weather damage, equipment loss, bureaucratic embarrassment filed away and ignored. Instead, somebody asked the right question. What if we did this deliberately? The answer transformed surplus weather balloons into instruments of strategic warfare. 35 shillings worth of latex and hydrogen drifting silently across the North Sea, striking infrastructure that no bomber could reliably hit. German defenders watched helplessly as attacks came from the sky itself, carried by winds they couldn't control, delivered by weapons they couldn't intercept, inflicting damage they couldn't prevent, making virtue from misfortune, solving problems with whatever materials happened to be available. That was the authentic genius behind Operation Outward. And that's why cheap British balloons destroyed German power stations, while the Reich's most advanced defenses proved utterly useless against wind, wire, and a little creative thinking.